My name is Shary. Most people call me Steve. This talk is on patterns and architectures beyond microservices. I am a principal engineer. I just transitioned from software engineer to AI engineer. So we'll talk about some of that. I'm sure many of you are getting pestered or feel pestered by the onslaught of AI and all that stuff. So we'll talk about that. I love connecting with people, so if you want to, talk to me afterwards, grab my email, find me on LinkedIn. I'm the only Steven Shary on LinkedIn. I say that, there'll probably be 20 of them tomorrow, but feel free to do that. So, if you start at your first job and you have a website and a mobile app, you did it, right? You've got your cog, that's your functions that are running. You've got your laptop, your desktop, and everything's running. You got a database, and life is simple. It's really good, right? You remember the happy times, right? Like back then, it was so great, and you just keep adding code to it, and it just takes over everything, right? That's the old Steve McQueen movie, and it overall encompasses and becomes this gigantic monster, right? And it was super cool to kind of make fun of this scenario 10 years ago. We call it the monolith, right? That just took over everything. And your code was just a giant amalgamation of whatever you were ingesting in. And you thought, hey, it's the 2010s. We can do better than that. Let's build some microservices, right? They did it over there in Netflix, pioneering that. We can do that too. You build a gateway or a reverse proxy, Nginx, Tyke, Apogee, one of those. You got 4 functions calling. You split it up. You're a software engineer. You're like, that's great. We did it. We're done. And you're like, oh, well, yeah, we're all still running on that giant monster database. But we'll just have that DB admin take care of that, right? Let's not worry about that. Maybe it's a SQL Server that's running 1,500 stored procedures on it, and you're just scared to even look at how many tables there are now, right? And you think, this is much better than we have before. But in reality, let's talk about the goals of microservices first. So the first goal of having microservices is that you don't need to ask permission to do things as much as you did before, right? When there were 10 teams and you were all working on the same code base, you had to talk with them, and now in microservices, you have autonomy. You can go commit code to your repo, you're good to go, right? You are independent. If you wanted to change the code formatting, if you were a tabs versus spaces, religious zealot, and you had control over your team, you could force it one way or the other, right? Maybe your opening brackets should always go on the next line. Maybe they should always go on the same line, right? You just totally get into it, right? And it's super awesome. The other thing is that you can take care of yourself. You don't have to constantly go ask permission to do things. Like, I would like to add a table in here. I would like to put in a new API endpoint. I would like to change how we log some of this stuff. You can just do it yourself, right? And the other great thing about this is, scaling-wise, it makes a lot more sense that if you have one thing that you need to scale up 10 times, you have 10 giant things running, where if you have something small that needs to scale up, the scaling factor hardware-wise is a lot smaller. And the 80-20 rule that we always see is that 80% of your traffic will run on 20% of your system. So you really only need to scale up 20% of your system, not the 80%, right? And so you can be much more targeted, much more efficient. And that's super great with microservices. Another thing is reduced risk, right? You no longer have to worry about, this is something we dealt with at my company, was you could log in on the same API server that you could upload images. And every day at 10 o'clock, we would have a number of our employees upload 10 meg images up to the main monolith system, and they would completely take down everything because the entire system was getting overloaded with all these image uploads. And by separating it out, we reduce the risk that if we take down the image upload service, it doesn't take out login anymore, and people can continue doing what they need to do. And then lastly, speed to deliver, right? I mean, how long does it take to run 500 unit tests versus 50,000 unit tests? Especially when the people on the other team that don't do a good job, right? Unit tests that take 13 seconds to run each test, but yours run in 3 milliseconds, right? So you have a lot more of this control to make things go faster. And then the other thing is you have this idea of heterogeneous workloads. That's kind of what we were talking about with image uploads before is sometimes you have to build a report. Sometimes you have to do a simple transaction like a login. Other times you need to manipulate large image data. Sometimes you need to get streams of data. And when you want one single service to do all these things, you deal with issues where you run out of threads, you run out of database connections, you run out of memory, you overload the CPU, and by separating them out into microservices, you can target those specific services into doing the things that you need to do. Let's talk about when you should not do a microservice, because I think this is really important. If you have less than 15 people on your whole team, don't do microservices. If you have 15 employees and 15 microservices, that's not a good pattern to follow, because then everybody just silos and does all their work, and everybody's responsible for their stuff, and it's just tons of blame pointing. You know, like, well, it's your service that took mine down, it's your service. And really if you have a small group, you work really well if you work together as a team. Also, if you have less than 100 gigs of data, it probably doesn't matter if you're doing some heterogeneous stuff like streaming and uploading and transactions. It's just not that much. If you're in a small startup, don't do microservices. Do the monolith, right? Rock and roll and go fast with a small team that does a good job that way. And lastly, if you guys write horrible code, and I'm not saying anybody here might do that, but taking one horrible thing and splitting it up into 10 horrible things doesn't make anything better. It just makes 10 horrible things, right? It's like pouring water on gremlins. Like, they just multiply and divide, and they will attack. Your services will just fall over on top of each other, and you have that one nicely disciplined, maintained, project that's doing a great job. But don't worry, because the other 9 will just completely trip over it and destroy it eventually. All right? So if you lack discipline, you think, let's go to microservices, that will solve our problems. That's not going to solve your problems. So this is what you wanted. This really nice thing. This is what you ended up with. Right? You've got AWS in the top. You've got a VPC down to your on-prem. You've got down in the on-prem, you have a PHP server with MySQL that's running underneath someone's desktop, underneath their desk. And you're like, I don't know what it does, but we turned it off one time, and we got in a lot of trouble, so we just turned it back on, right? You still have that monster Oracle database from like the early 2000s, and it cost you like $3 million to run it, but it cost you $30 million to move off of it, so you still keep that, and that's horrible. And Oracle will only allow you to transfer it to the Oracle cloud, and you're not doing that, right? And this is kind of like what we end up with, right? And you think, was this really better than what I had before? Oh yeah, you got that Access database over there, right? Don't let that one get away from you, right? Yeah, HR, they won't let go of that bad boy. I see people leaning over there like, oh, he knows what we're doing. It's at every place, right? There's a gray box in the corner. It just points to itself. You don't think it's connected to anything? It shouldn't be. There's no Ethernet connection. It has no Wi-Fi card. But it just sits there and runs, and there's a Post-it note that's been duct taped that says, do not turn off, right? I mean, this is kind of what we get into. And what I want to pitch in this are some techniques and strategies that, in reality, this is the microservices that we live with. This is the microservices that I have. I have some Perl code running that we can't kill at my company, and I would love to kill it, and it's just not a business priority, right, to get rid of it, and it probably gives us about 5% of our company's revenue runs off that service. So we want to kind of talk about some strategies to do this. And it keeps going, right? You have this ridiculous thing, and you just keep adding on to it, right? Because you should be paying off tech debt, right? But now your CTO has come along and says, hey, we should think of our debt as a strategy to propel us into the future. And they take this concept of tech debt, right? And they use it incorrectly, like they're going to use debt to be able to leverage innovation, to grow, and you're like, no, these are just problems that I got to deal with every single day of my life, and you won't let us fix it. And so you keep growing, until one day, this is what you end up with. And you think to yourself, it's a trap. There is not no moon you're looking at there, my friends. You know, and it's like, with this power, we can now destroy entire planets. If you're like, what in the freaking world is this? This is from a guy I know, Bruce Wong. This is what Netflix's microservice connection map looked like on App Dynamics. That was their APM that they used. I can't even imagine that. You know, that's kind of insane. And so here we want to talk about what are the architectures and patterns that we can implement in microservices to kind of make things even better. Because we didn't necessarily, we moved away from the monolith, which there were some problems associated with this, but we opened ourselves up to additional problems and issues that we have to deal with. And so I want to present here some of the patterns and architectures that we've done at my company that have helped improve us as we move beyond microservices. The first one is documentation. We're going to talk about this. We're going to talk about centralized telemetry. We'll get into that. We're going to talk about service communication and its directional flow of how you want to do it. And then lastly, we're going to talk about the concept of bulkheading, okay? And we do all these things. And so none of these things that we're going to talk about are theoretical. These are all things that are tried and true practices that we use. Documentation. Good documentation is up to date. You could say that no documentation is better than wrong documentation. I've heard that before, right? But good documentation is up to date, and it matches. Better documentation is stuff that lives with the actual code that it does, right? I don't want to have to go to a wiki page or a Confluence page or a GitHub page and then go over into my code base and try and map which functions and API endpoints and things like that, which components, right? And the best documentation that I have is the code. And no, comments don't count, right? Because nowadays, nobody really reads the comments, and let's face it, I just do /*, and I wait for GitHub Copilot to auto-complete that, and who cares what it says, because it looks really nice and it's all formatted, and it, you know, things like that. So let's talk about that. The best documentation that I really like to use is OpenAPI, and this is where all of our endpoints are defined on our API as JSON data. And the requests and the responses are defined. And OpenAPI, which you might hear Swagger. Swagger was the original project that turned into OpenAPI because Swagger's a goofy name. And there's a nice UI associated with it. There's tons of support for it. I don't think there's a language or framework out there that doesn't support OpenAPI at this point. And I would also say is that there's this newer trend that's growing that not only with your API, with OpenAPI, you know, the specs, and we'll kind of show that real quick, is you should start thinking about having a request collection. So this might be something that you have with like Postman, where you have a series of example requests and what those responses would look like to give people that need to use your API a hint as to how to use this. So when you start this up, you'll have an OpenAPI definition. This is the generic one from Swagger that they have. And you can see that all of this stuff, right, this is a web page. You point it at this JSON object that's generated from your API, and it it shoots out all these different things. You can actually click onto these. You can hit try it out. You can put in auth tokens, which is really cool to be able to handle authentication if you need to do that. And so what I really recommend to make this where your code is your documentation is that you decorate all your request and response models. So what you're doing here is that all your API input parameters and all of your output responses are typed fixtures. If you were at Corey House's talk on testing, he was talking about using types as a way to test. This is using types as a way to document, which I think is a great idea. And so if we look at Python, I'm just gonna go here. Python's a pretty simple language to kind of like grok and understand. But in Fast API, what you do is you define your class, which here it's item, which extends from base model. This is just a pydantic thing, which is a way to structure your data. And we have the name, description, price, and tax. And you can see name is a string, and description is a string or none. And a price is a float, and tax is a float or none, and we can set default values. And then we create the Fast API instance, and we define a post endpoint for this. When we do this with Fast API, you can do this with Spring Boot, you can do this with .NET. I know that you can do this with, well, in Node.js, you can do this with Nest.js or SOA. I know it's supported in Golang. I don't remember what that is. But with all of these, what you end up getting is back here, we had that post, and now we have post items, and we have name, price, description, and tax. And we can have the types that are in there and all that stuff. And many different frameworks will even will take comments that are properly formatted with that type, and they will put that into your OpenAPI documentation. And we can see here very specifically is that we have this. And each place has some just simple syntax that you can decorate with that to even provide stuff. You can do stuff like regexes, even when you have types. So you might say like, hey, this is an address and this is a state. And then you list out all the available states that you can use. And it's all the 2-letter abbreviations, right? And you don't have Puerto Rico in there, and they're not allowed to choose that because it breaks everything. And the only thing you're allowed to do is just the 48 plus 2. And all of that was just based on the model. I didn't have to type any documentation. Now, that's really great, but I have these like 10,000 services that I'm running, and I'm like, how the heck am I going to find all these things? And so what we want to do is combine that all together and have a centralized place where people can be like, where do I find all these APIs? Where do I find all this amazing, beautiful documentation that you have that is your code that's running today? And so at our company, at ACV, we use Backstage. This is an open source project provided that Spotify created. It's pretty good. There are also a number of other alternatives like OpsLevel, Port, Cortex, Compass. Compass is an Atlassian product. If you're in that whole ecosystem, you can do that as well. And if you go to our Backstage today, you can see here that it shows all 81 APIs that are available for you. So you can just browse through and look at our different APIs that are available, and you can test these out and try these out, and you can get like the URLs where they work, all that stuff. It's super great and makes it really easy for engineers to explore and understand how your code is available. This is a recent one that we have. We have an LLM RAG model chatbot called ACE at ACV. And this is an example of our actual stuff. And some of the cool things are like the gray bubble up there shows an actual, like the Git hash, Git describe, so you can actually see like what version we're running. So if you run into a problem, you can come to me and say, hey, I'm running version 175 and I'm having this issue. I'll be like, don't worry, like we're on 176, just try it again. The next thing up that I wanted to talk about here is centralized telemetry. Quick show of hands, I know there are people in other places, who here is using telemetry with their production systems? Okay. I hope everyone raises their hands, because if you're not, you just don't know what's happening in production. That's frightening to me in entirely scary ways. But when you run microservices, you need to centralize and bring all this stuff together because you have all these different systems, and they're all doing different things. And if the first thing that you've decided to do is write all your logs to a file that's running on a server that's separated from all the other ones, it is the absolute worst to try and debug and figure out a production issue. And so the first thing is that all your logs should be centralized into one system. If you're not sure, like, what would I use for that, there's a ton of different things out there. Elk is a really great one, easy to use. If you're using one of the cloud providers, I know they've got decently, they're kind of crappy solutions, but they're functional, you know, and they'll work for what you need it to do. So at our company, we require that all of your logs have to be in JSON format. So one of the things is that we don't want you to do string concatenation for your log message, right? Because then when I'm trying to parse through all these logs, I got to use regex to break apart because you decided to say, like, you know, build 47 wasn't added to box 13 that's being shipped to Arizona. And I'm like, what? I just need to know which ones are not being shipped. And when you like try and put all those together and you make this dynamic string in your log, it's very difficult to go and parse and figure out like how many times has this been happening. You start writing regex. And let me tell you, like I had a friend that said, if you have a problem and you use regex, now you have two problems, okay? And I know that you can go to ChatGPT and be like, could you please write a regex for me that finds this thing, right? But when we're dealing with production issues, we don't want to do this. So what we actually recommend at our company is that the message should always be static, and that if you want to have dynamic data associated with it, like what's the destination, what was the original order ID, how many things were in the box, those should just be added on as extra parameters as part of your JSON log. And actually, interestingly enough, that functionality is supported across every single language. If you're using Serolog on C#, if you're using, not log4j, don't use that one. You'll get hacked immediately. You know, on Python, we have our own JSON logging, but you want to do that. The next thing that you want to do whenever you log is you want to start thinking about tracing, right? Tracing is the concept that we have a trace and we have a span. And the way you want to think of it this way is if you've ever had a stack dump, you know, where you had an exception, you had this function called that function, called that function, called that function, all the way down. The overall stack trace, that's a trace, and each individual line is a span. When you're dealing with distributed microservices, a span can be from one system to another system to another system, and even within one system, you might even have a full stack trace. So you can see like, where was the controller or the route code? Where was the database service that was trying to call this? Okay, and you can go all the way down. And if you do it well, if you connect all of those together, right, you can attach your span ID and your trace ID to your logs in an automated fashion, right? You intercept your logger and you decorate that on. And now what I can do is I can take an entire single call that goes through multiple different systems, and I can get all the logs associated with that one call, right? Because you're going to be like swimming in terabytes of log data, right? At my current company and at my last company when I was at Kroger, we generate over a terabyte of log data per day in production. And it is an unthinkable amount of data to try and parse through, right, if you're trying to get through them. So let's talk about what a trace looks like, because I think this is important. Up here, we have example trace. This is using Datadog for the telemetry. I like Datadog. I have used AppDynamics. I've used New Relic. I've used Elk, which is Elasticsearch, Logstash, and Kibana. And I've used Datadog. I've also used Splunk. That's pretty much just logs, but they do have some telemetry stuff that they've tacked on. But in this, what you're looking at is what we would call like a fire diagram. And at the very top, we've got this is the first thing that came in, and it calls something, and it calls something, and it calls something, and it's going all the way down. And you see it kind of pop back up. And you might think to yourself, that's insane, because each major color change is going to a different system, and these are HTTP calls. And you're like, that's totally insane. This will be ridiculously slow. But in actuality, it's not that slow. This is our search functionality. So if you call the search endpoint to be like, we do auto auctions. So if you say like, show me some auctions, like I'm really big into soft top Jeeps. That's what I want to look for, right? In 24 milliseconds, we'll have gone through everything. And these are the different services in Datadog that I can kind of see that I start with my gateway service. I've got Elasticsearch, which is my database. I've got my search service. I've got my projection service, which provides the context for each matching thing that I'm searching for, right? We do the concept of a BFF, a backend for front end, not best friends forever. And then we even have like some of the client code in here. And it's really nice because if you end up with a, let's say hypothetically, I've helped out a team that had a 14-second HTTP call, an API call, and they're like, I'm like, why is it 14 seconds? And they're like, I don't know. It takes us approximately like 3.5 seconds to look at their call to figure out that they had a database query that took up 99% of the time. And then we're like, why did that database query take so long? We run an explain plan on the query, and then we find out that they're missing an index, and they're doing a full table scan across 34 million rows, right? And so you're like, oh. And if you don't have these distributed tooling and logging set up, and you're running a microservice architecture, you are going to be swimming in piles of trash until you think that you found it. But when you are using distributed tracing and telemetry like this, it happens immediately. It happens immediately. And it is really fast, and it does work really well. This is an example of our logs. I said that we have JSON logs, and this is what they look like. So up here at the very top, I can't even see that from here. Up here at the very top, we have what we looked for a trace ID. And you can see that we have a table, and it's just showing me a whole bunch of these different logs that are in there. But even looking at the individual log rows, you know, I can choose which columns I want to represent from the JSON. And when I click on it, over on the right side, I have a huge number of things that show up here that I can take a look at. And I think this one is coming from a .NET version, a .NET service. And so I get tons and tons of contextual data from all of this stuff. And even within many of these services like AppDynamics, New Relic, and Datadog, you can even see which logs are associated with which spans of that flame graph to kind of be like, why did this happen? Like, please give me a hint that I can figure out if I need to roll back a commit or I need to go fix a bug, right? Let's talk about service communication, because this is a horrible, horrible problem that we can also have to deal with, right? Let's say that a call comes in, right? Someone from the internet has decided that they want to talk to your system, and you think, should I just expose an API straight on Postgres? I don't know. Maybe that's an idea. Should I run it through some sort of security thing? How should I do this? And you start to figure out like which services can handle external communication, which ones should only talk to each other. Where do I handle authentication and authorization? And you think, oh, someone else probably did that for me. I won't worry about it. You know, that's a major problem. And really what we want to do is maybe you've gotten like into the hyper cool kids club, where you are running Lambda functions, and you're like, this is the coolest thing ever. And now your Lambda function makes another call to another Lambda function, and you're like, I don't know what that Lambda function calls, but it does whatever I want. But you didn't realize that like 6 calls later, that Lambda function is actually calling your Lambda function back again. And only through like just pure coincidence, you have an if statement that routes that Lambda function to a different one that doesn't send you into an eternal loop. And the ThoughtWorks radar, I don't know who came up with the term. They called it Lambda pinball, which is basically like you shoot a request up into the pinball machine and it just bounces all over the place. And so what we really need to do is start coming up with this idea of how do we come up with a strategy that these services are allowed to talk to each other. And what I really pitch at our company is the concept of a layered architecture with layered responsibilities. So at the very top, we have security, then we have authentication, then we have aggregation, then I have authorization, then I have business logic, and I have my data layer, okay? Let's just talk about each one of these real quick. Security, like, is this a DDoS? Is this a foreign actor that is trying to break into our system, right? This is the thing that we put in the very front, and we'll talk about the different things that we can use for that. The next is authentication. This is a really easy thing to mix up with authorization. The quickest way to know this is authentication is, who are you? And authorization is, are you allowed to do that? I realize that you have a bank account with us at our bank. Are you allowed to withdraw $1 million from someone else's bank account, right? So authentication is, who are you? And authorization is, are you allowed to do it? Within microservices, likely what will happen is that the front end does not want to make 55 calls to the back end to each individual service, and you will need to aggregate those things together, okay? And then you'll notice that authorization that we just talked about is not next to authentication, it's down. And that's because I think authorization and business logic go hand in hand. Are you allowed to withdraw money from your bank account? Probably. Does it depend on how much money is in your account? Probably. Does it also depend on if you're a person who's assigned to that account? Probably as well. Hey, maybe you have a CD and you do have a balance and that is your account, but according to the rules of your CD, you're not allowed to withdraw money. In all of those situations, we're kind of mixing in the business logic and are you allowed to do it together? And I see authorization and business logic sitting right together pretty closely because you start getting into these scenarios where they're like, hey, I can do this, but only in these situations and not in those situations and things like that. And then the last is the data layer. That's on the bottom. Don't put your database on the top. Don't do that. And then don't do the thing where you decide to smush all the layers together, right? Keep these things separated. They work really well when they're separated. They don't work quite as well as they're smushed, right? Maybe you're writing some PHP code. Maybe that PHP code is handling authentication, and in the same function, you're making a SQL call that you didn't check for SQL injection attacks, and maybe you're accidentally letting someone take over your database. And that's something that we see, I think, in architectures where they smush things together way too much, and it's too easy for engineers to make a bad mistake that causes significant damage. So one of the things that we do is we have an acyclical directed graph as a requirement for what we're doing. And what this means is acyclical means not a loop, not a cycle, and directed means it goes in a certain direction. So our calls always go down. We discourage horizontal calls, and we highly discourage calls going upwards, okay? So what this means is in our system, we might have an F5 or a WAF for security, and that calls the gateway, which does the JOT token validation. And that might call my BFF or GraphQL layer that would handle aggregation, right? Maybe you're running Apollo. Maybe you're just doing a BFF. Maybe you're doing, I don't know, whatever you're doing, right, to aggregate. And then your authorization, your business logic, those are down in your microservices. And then you have your database, your data store layers, mostly databases, but some people have S3 buckets or a GCP bucket or, I don't know what Azure buckets are. I'm sure it's an Azure bucket or something like that. So you have that, right? So let's get to the bulkhead pattern. The bulkhead pattern is not like a circuit breaker. It's the fact that we want to group traffic either by the client, the front end, the team, or revenue streams, okay? And what we want to do is we don't ever want to have one system to be able to take down other system, right? The Titanic was fantastic, it was great, but it still sunk to the bottom of the ocean, right? And what we want to do is have the concept of a bulkhead, this is in a ship design, where they can take a major hit to the ship They can close the doors that are bulkheaded, and the ship will still float along. It's not doing great, but everybody's not dead either, right? And so if we take this and we use my super awesome diagramming style, and we think of this as like a ship, when we draw a bulkhead, we want to put it so that one doesn't go down the other. And the problem we have here is in the red line is that one aggregation layer is talking to the other. And we would say, like, well, if service 2 goes down, service 1 is screwed, essentially, because all of its data is tied directly to it. And so what we do is we want to share the data with other people. How do we do that? We need to start thinking about how we want to store our data. And we do this at our company where we say our source of truth for our data is not in our database. None of our systems have the source of truth of our data in our database. And we use eventual consistency, and we store all of our data in a Kafka topic, or Kafka topics. We have a Kafka cluster right now with over 15 terabytes of data. I know some of you work with a lot more data than we do, but Kafka is scalable. And every change that happens to our system gets stored into Kafka. And then what we do is we read out those changes to our data, and we project them into a database so that we can see how it's stored. And what happens is that if your team needs the data from another team, instead of calling their microservice, what we would say is, why don't you just create a projection of their data into your database? And that way, if their system goes completely down, you don't care, because you're just using a projection of their data. You might say, well, I don't have any updated data since their system went down. Well, don't worry. They don't have any updated data either, right? But what you got is the latest of what they're doing. And so CQRS is this concept of command query responsibility separation, where you say, anytime you want to change the data, I have a transactional data for consistency. But then once ever that change is made, I publish it, and then that is read in through a projection and is used in other places. You might say to me, Steve, that's nice, but I have to do real-time stuff. And we do too. We're an auction company, and we have online real-time auctions. And all of our auctions that are being shown to the customer are built off of projections. We don't use any of the transactional databases to show customers what the current high bid is. We show projections of all that. All right, so some guidelines. Events are immutable. If it happened in the past, you cannot go change the past. This is not like that Marvel movie, right, where they went back in time and they changed it so that Thor couldn't get his hammer or something. And I'm probably you probably don't care about me anymore because I don't know the Marvel movie well enough. But these are things that don't change in the past. And when you publish an event, if you're the auction team, you publish auction events. And if you're the box shipping team, you publish box shipping events. You only publish events for what you own. And you make everybody can consume your events. And we keep all of our events for all of time. I have every single auction view and auction bid and auction launch and car inspection and login that has happened since our company virtually started, right? We have them forever, and it's great. And then we also say that your consumer should be idempotent, which means that you can run these things over and over again, and it still has the same thing. So if you have a function that says, hey, I'm going to process a new bid that happens, right? You need to make sure that if you receive that bid multiple times, that you don't increment the number of bids each time, is that you just have a count of the number of distinct bids. We define our event structure and our models. I think I'm running low on time, aren't I? Do I have 5 minutes? OK, I'm going to go faster. Let's say that you can't be as cool as this and you need to go faster. You can do a poor man's CQRS, and you can just make a read-only replica of your database and hand that out to other people to use, right? That's something that you can do. It works pretty good until it doesn't, and then it abruptly stops working pretty well. I think we're at the max of read replicas allowed on a single database in AWS. You can only have 13, and we still do this in some of our places. And your writes should be atomic. if you're really interested in moving past that, there's the concept of change data capture on databases. But now we have a wonderful working architecture, and you feel great. Everything's going well. You can track everything. And then your boss shows up. And what does our boss say to us? We need to do a whole bunch of AI stuff. And you think to yourself, oh, I have no idea what this is going to work like. And to be honest, it's totally different because AI is a probabilistic system, okay? And it uses linear algebra based on the inputs. And it uses a ton of compute. It's in a totally different data format. It's not always right. That sucks. And it's not always consistent on the same input. If you be like, hey, how are things going today? It'll be like, good. And then you say, hey, how are things going today? And it's like, okay. How are things going today? Good. How are things going today? I don't know. And you're like, what? And additionally, the data format for machine learning models is totally different. And machine learning engineers are like, I need all your data. I don't know what's important, and I have to build a model and figure out how to do it. Okay? And their data formats are really, really weird. Okay? Whoop. When you think about like categorical, they do one-hot encoding. They can do labeling for text. You have word embeddings, tokenization, lemmatization. Images will take like a 4K image and reduce it to a one-dimensional vector. That's 256 by 256. We have autoencoders. There's just a ton of nutso stuff that happens with all this data. And so the long and short of it is that you really need to think about decoupling your database data from what the ML engineers need to do. And CQRS is a great way to do that because they want to know like what happens when things change. Like, why did this person look at this ad? When did they click on the button? And when you just say, here's my database schema, they spend 9 months trying to rearrange that data until they can finally put it into something called a feature store. The other thing is that if you decide that you want to put an ML model or AI into your system, is that you have to know that it's not going to work some of the time. And ideally, you should be able to figure out when it doesn't work. If you have an ML model that works 100% of the time, most ML engineers would consider this a bad model, which you're like, what? But they would consider called overfitting, where they overly trained it, and when something new comes in, it will likely not accurately represent it. And so you need to always have edge case detection, both on the inputs and on the outputs, right? We need to look for people that are trying to game the system, and we have to realize when the AI gives you completely ridiculous results. So always build a system that will return empty or failures on edge cases. Do not hook up your ML model straight to the internet. Bad things will happen, okay? I'm sure that you all can think of many types of cases where this has happened. We also need to retrain our data periodically, and we also have to have a way to verify the accuracy of this. This gets me over and over and over again where I have someone that's come up with a new LLM that they want to put into their system, and it gives a summarization of the data for them to use, and then we ask the question, how do you know if the summarization is good? And they're like, well, it makes sense. And I'm like, but how do you know it makes sense? And so if you are working with these kind of systems, make sure that if you're using a probabilistic system, is that you're trying to look for it to cause the customer to do a certain thing. I want them to click on a button or add an item to the cart, or I want them to do an action I'm looking for, and track that data. If you don't do that, this is very, very bad. And you're basically, it's like the Wild West. You're just throwing a chatbot out there, and you're hoping that they won't file a lawsuit within 6 months. So avoid using models that you cannot verify the accuracy of a single result. All right. Sorry, I like smashed through this. I think I'm at time. Thanks. If anybody has any questions or anything, are we open for questions right now? Or? Okay. If anybody has any questions, we went through a ton of stuff, but I'm really hoping that this gave you some ideas around what it looks like to live in a post-microservices world and what are some of the things that you need to think about. So thank you very much.